So I'm going to be talking about powering TensorFlow with big data, Apache Spark, Flink, and Beam. And I also am going to wear shoes which light up when I stomp. So if I'm stomping and you're in the back, it's for dramatic effect. Just pay extra attention. OK. So my name is Holden. My preferred pronouns are she or her. It's tattooed on my wrist in case I ever forget in the morning. And I'm a developer advocate at Google. It's great. They pay me money. In exchange, they receive things. And slide decks and software. It's fun. I am on the Apache Spark PMC. You can think of that as being like a committer, but with tenure. But it's a kind of shitty version of tenure because they don't have to pay you. It's really hard to get rid of me now, though, so that's great. It's one of my life goals. And I'm also a contributor to Beam. But like they can get rid of me whenever they want. I'm just a contributor. And I've previously worked at a bunch of other places, IBM, Alpine, DataWorks, Google, Foursquare, and Amazon. I'm a co-author of 2 books. I got much better royalties on the second one. It turns out you can negotiate. And so definitely buy this book. I don't know if anyone actually wants it, but you should buy it. You can follow me on Twitter. I also have started doing live-streamed code reviews inside of Spark, and so if you're interested in seeing how Spark code is developed, you can follow me on Twitch and YouTube. And when conferences give me videos of my talks, I try and also post them on YouTube, and you can follow that there. In addition to being who I am professionally, I'm trans, queer, Canadian, in a work visa in America, which is just a lovely, exciting time. OK, this microphone is annoying me. Sorry. And part of the leather community. And this isn't overly related to TensorFlow. We're not going to train it on flags. But I think it's important to remember that we all come from different places, and we should be nice to each other. This stuff is hard enough without yelling at people on the internet for no good reason. Cool. So I'm hoping you're all nice people. You've laughed at some of my crappy jokes. And actually, this part here is maybe not so true. How many people are familiar with Flink? That is a lot of people. How many people are familiar with Spark? Thank God. And how many people are familiar with Beam? Lovely. More people than I expected. So that's lovely. The demos today are going to be in Spark and Beam. I took out the Flink demos because, yeah, they crashed 3 times. OK, so, and by demos, I really actually just mean the slides. I can run the demos on my laptop if we want, but it's up to you. So there are 2 things that I'm going to talk about today, which work on Beam but do not work on Beam on Flink right now. And I'll talk about why they don't work on Beam on Flink and how we're going to fix that. But there's 2 pieces that, if you try and go and use them in happy open source land, they're going to fail. But we'll fix it eventually. But there's some really cool things that we did get to. I drank a lot of coffee yesterday, and I got TensorFlowOnSpark to work with Apache Arrow, which I found incredibly entertaining. Python and Go on Beam on Flink kind of work. Not completely, but we'll talk about how we're going to bridge the gap to get to TensorFlow with it as well. And there's some other stuff for handling portability and also handling dependencies. But I want to be clear, some of the things we're going to talk about today, if you run them in production, you are going to have a bad time. I keep a resume up to date just because my job is giving talks to people sometimes. I say bad things, and it's good to have an up-to-date resume. But it's never good to have to update your resume because you're scheduled batch job run. And if you do this, you might have to. So just don't do that. OK. Clicky thing. Yay! So we're going to talk about TensorFlowOnSpark, a little bit Flink, and Beam. I'll talk about Apache Arrow and how this changes everything for a very flexible version of the word everything. It changes one tiny part of the world, but we can extrapolate it. And I'll also talk about why some of the parts that I wish I could show you in Beam aren't quite working the way I want, and we're just doing them directly in Spark instead. OK, cool. So before we get too far, we should understand how PySpark works. And this may seem kind of esoteric, but TensorFlow is written mostly in Python. That's where all the nice APIs are. And even if we're working in the JVM, we're going to end up using some of the Python pieces underneath the hood. And it's a combination of pickling, sockets, pipes, and I couldn't figure out an image for JSON. And at least this isn't XML. So, oh, okay. I will update this for the horror movie reference for Spark Summit San Francisco. Thank you. I appreciate that. That's good. Okay, so it's PySpark is the Python interface to Spark. If anyone's actually interested in languages besides Python, it's the same techniques that we use to make all of the other languages, except for JavaScript, work with Spark. JavaScript is special in its own special way. And it has some pretty serious performance hurdles, which can really impact us when it comes time to do like big deep learning, because deep learning involves lots of data, and our performance hurdles in a big data system unfortunately involve the big part of that data thing. So let's figure out why. So this is the architecture design diagram. And you may start to be getting a hint as to why this doesn't run super fast all the time. On our worker processes, which is where all of our data processing is happening, we first load the data into the JVM, and then we go and say, hey, I know it's fast, Unix pipes. And then we open up a Unix pipe to talk to a Python process. And that's not good enough, so we also open up a socket to send other information over. And then we send our data over a combination of this pipe and a socket in a manually serialized pickle format. And Java implementation of picklers are terrible. It's pretty much doing things that Java is really bad at, like shoving bytes together. And so this is kind of slow. But it works, and it scales horizontally, so you can just buy more machines. And as a cloud provider, I think that's great. You and I might not be completely aligned on this point. And so we'll talk about how I'm working to make my employer less money. And in Flink, it looks pretty similar, except they looked at sockets and went, no, memory mapped files are far cooler. And it turns out, yes, memory mapped files are far cooler, but when you don't actually just manipulate the data, you still end up copying it in and out on either side. They don't give you anything nicer. So better design, A. Implementation is still a solid C. Okay, so how does this impact Python on X, and therefore TensorFlow on X? We have a double serialization cost. There's a bunch of random overhead pieces. One of the things that you will almost certainly come into if you're using TensorFlow is that the error messages make no sense. And that statement could be about TensorFlow or Spark, and in this case, it's about both. Yay! You can get a TensorFlow Python error that is wrapped in another Python exception, that is wrapped in a Java exception, that is wrapped in another Java exception, that is then wrapped in one final Python exception. And this delightful onion, you may receive up to the number of machines in your cluster, copies of it, times 2. And so you could get like, let's say you make a typo in your TensorFlow code. You could get like 2,000 error messages, all of which are pretty much impossible to read. And this is great, and I love version control. Oh dear God. The other one is dependency management makes limited sense. And this is really inconvenient, because if we want to use cool deep learning libraries, I need a bunch of dependencies on my worker that may not already be installed by my cluster administrator. Especially if I'm like taking an existing sort of ETL pipeline or ETL cluster, there's a really good chance that my stuff that I need isn't going to be installed. And we're working to make this suck less, but for now, it's terrible. So that's cool. So, okay, has anyone played with the TensorFlowOnSpark project from the Yahoo people? 3 people, very exciting. 4, one of them is my former coworker though, so it doesn't really count. I'm sorry, man. Anyways, so it turns out someone looked at TensorFlow and went, yeah, let's make this run on Spark. And it turns out actually about 3 people did that, and they made separate competing projects to do this. And one of them is TensorFlow on Spark, and I'm not saying it's good or bad, but it is the simplest to put Arrow into the middle of, so it's the one where I did that. And so you can essentially take your existing TensorFlow graph, and that's just all extracted away inside of mnist.csv. data fun and some of the other functions here. And so you take your like normal regular TensorFlow setup, you put it inside of some lambdas randomly, probably give them names, and then you just call tfcluster.run, and then you call cluster.train, and it's great. It probably works. There's also like a 30% chance in my personal testing that it just fails and then you run it again. And that's totally cool. Totally normal. Software is great. Okay. So we're not going to make it more reliable. We're actually going to make it moderately less reliable, but we're going to make it no longer as slow as my delightful stuffed animal Boo, who cannot walk under her own power, and as fast as this picture of a cheetah that is also not moving. Sorry. And so we're going to use faster interchange. How many people are familiar with Apache Arrow? Are those there? I'm seeing a lot of the like same 4 or 5 people. And I feel like we may have undertaken similar projects in the past. But Apache Arrow is this really cool project that looked at the JVM, looked at Python, looked at R, and said, wow, all of these things have to work together, and everything we do to make these things work together sucks. We should try not being terrible. And they did, and it's really awesome, and it's a lot faster. And if you believe vendor benchmarks, you may have seen this one in the morning if you went to Yambo's talk, this could make it up to 242 times faster. It's not. But it could, right? And those are the kinds of benchmarks that you have to publish to get a PR merged in Spark. Oh, dear God. More realistically, we're also probably not going to see a 3 times speed up, but we're definitely not going to see order of magnitude level improvement. But it's going to be a lot faster. And so you should definitely go and read this benchmark and attempt to reproduce it with things that you care about and see what your personal performance numbers are, rather than just trusting me, because I don't even trust me in this case. And so this is using Arrow. And essentially what Arrow is it's this really happy thing where like Java and Parquet can also understand the same in-memory format. I can also talk to well, it's more that Arrow can understand Parquet rather than Parquet understanding it, because Parquet is a file format, but whatever. TensorFlow can sort of talk to Arrow, emphasis on the ish part, but it has like native support for R, Python, and the NVIDIA people were like, I want in on that party. And so you can also understand the data format in CUDA. And this is really great because we have this problem where we essentially need to take a shit ton of data and get it onto a GPU. So this looks like promising approach, right? Maybe? Okay, I thought it was a promising approach. So we're going to start off with rewriting, adding 2 numbers together, because rewriting TensorFlowOnSpark did not seem like the best place to start. So we can take this very fancy lambda xy. Java people just pretend there's a lot of angle brackets and types here. And then we add 2 integers together. And we all know that Python is good for numeric computation. So this is legit. We're adding 2 numbers together in Python because we can't trust Java. I joke. OK, or we could actually go inside of TensorFlowOnSpark, and we can find the part where it's doing most of its work. It's actually doing its main sort of parallelization on this thing called a union RDD with a for each partitions. And the union RDD is just all of your data replicated the number of epochs that you're going to be running. And then it runs this for each partition, which just naively serializes this TensorFlow on Spark train code and just calls it on each worker. But we can go ahead and we can turn this into something magical, just like the last slide. The sad part is it's not going to fit on 1 line. And so instead, by stripping out all of my assertions and tests, it can fit on 1 slide. And so inside of TensorFlowOnSpark, we just do a minor bit of refactoring. And we return some dummy numbers because we don't support returning none right now inside of our UDFs. My bad. Hashtag, we'll fix that later. And then we get into input series. And this is cool. It's not quite what we want, but we do get to use Arrow, right? So if we go back here to my very high quality diagram, we get to use Arrow to get our data into Python. So it's going to go faster. We could pretend it was going to go 200 times faster. We all know it's not. But it's going to go faster than it was without it. So that's cool. And now it looks like this. Java goes to Arrow, which goes to Python. Oh, this line should have been black. Anyways, like we can get data from Python to TensorFlow. That part actually works. And this is not great, because I still have the overhead of having a bunch of Python objects sitting around that I don't really need. I really just want to go this way, and maybe have like also Python talking to TensorFlow. In this case, we're talking about the like gnarly C++ binaries that are just ugh. So I want a Python interface over it, but I want my data to not flow through Python, right? Turns out that's hard. So there's some things that need to get improved inside of TensorFlow for matching Arrow, or inside of Arrow for matching TensorFlow, depending on how you look at the world. And as someone who doesn't have access to the TensorFlow repos, I would say that we should improve Arrow, because I can directly impact that more easily in my life. And we can probably eventually strip this part out. We can avoid funneling the data through Python native types. And we can use a shared memory buffer. We can steal that part from the Flink design and be like, yes. And then, instead of copying my data 3 times, I copy it once. And then eventually, maybe I'll like not have to copy it. I can just directly write it in. But that involves me getting the other Spark PMC and committers to agree with me on changing a data type, and that's just not going to happen this year. But you know, maybe everyone will go on a ski vacation and they'll come back to a new version of master. Who knows? This talk probably is being recorded, so I should clarify that is definitely a joke, 100%. Okay, so that's cool. TensorFlowOnSpark is still kind of a pain to work with, though. And if you were in this morning's talk with Yambo, you may have seen like Spark deep learning pipelines, and you're like, why aren't we just using those? Those sound way easier. And they are easier to work with. They're pretty cool. Yee, light up shoes. They're not really great, though, for everything. It's pretty much, if I want to slice off the end and do some transfer learning, Spark deep learning pipelines are really cool. But I can't like take a TensorFlow graph and be like, yo, train on this. It's just like, no. That's not what I do. And so Spark deep learning pipelines, way easier. And conveniently, they also happen to use Spark's distributed data frames. And Spark's distributed data frames are the only thing that Arrow really understands in SparkLand. So we could put Arrow in here too. And we could make this go even faster as well. I just only wanted to make it go faster in one place because I'm giving a second talk on this in a month, and then I can have something new for each one. But it's the same technique. We'll rewrite this, you know, for each into a UDF that returns some null values. It's super great. Other options are, if you don't want to use TensorFlow, that's totally OK. There are other deep learning frameworks that would like your money. I mean, it's open source, so they would like your CPU hours. I don't really care. I'm a cloud provider. Whatever software you're running is still software that you're running. DL4J, also friends. I think they have Arrow support. I took a look in their repo, and I couldn't tell for sure. But they had like an Arrow Java file in there, which was like a pretty good sign. I just couldn't figure out how to use it. That doesn't look good. I'm going to go ahead and click cancel and hope that my presentation continues to work. Oh, dear. Yay! OK. Another one is, if you're a Flink user, you might be like, Holden, that's fine. I don't want to use any of that Spark shit. Totally cool. There's Flink-TensorFlow, same party. No Arrow integration in Flinkland right now, though, so we can't do the same cool trick that I showed you. But this is all well and good if I want to like essentially recreate results from papers, right? There's a good chance that your data is probably not ready. There's this thing called feature preparation and data preparation. And even though deep learning is this magical sauce, which is totally for sure this time the real AI, and it's going to fix all of our problems, and we don't have to do any feature engineering, for some reason, it seems like most people still have to do some feature engineering, and that's totally fine, right? Maybe it's kicking out invalid records, totally legit. And so there's a bunch of tools to do this. If you're a Spark user, you can just write some Spark jobs, but then the problem is when it comes time to serve it, you have these Spark jobs which run on your Spark cluster for doing your feature prep, and now your serving layer doesn't, oh dear, because you need to recreate your feature prep in your serving layer, and so it's all kinds of sadness. And so TFX and friends, TF.Transform, TF serving, and there's more friends coming, are an option to simplify this somewhat. The alternative is piles of custom code, and as far as I can tell, that's what everyone does right now, including myself. There's nothing wrong with piles of custom code. It's how I have job security. I never really like it when I have job security. That's a sign that my job is kind of shitty. So TF.Transform is for pre-processing our data, e.g. where we spend 90% of our dev time anyways, right? Like, I don't spend my time like playing with cool new features in TensorFlow. I spend most of my time trying to like figure out why I have some junk data about dogs messing up my cat's label. You know, those are the problems that I face. And TF.Transform integrates into serving time, and it runs on top of Apache BEAM. But it depends on this really cool new design we came up with, but didn't finish implementing in open source. It kind of works. It definitely works on Google Cloud, of course. You know, if anyone wants to use Google Cloud. But it'll work outside of Google Cloud too soon. We're working on it, I promise. And so we can define our pre-processing. We can send our inputs. We can normalize things. We can convert our strings to integers. All very exciting things. There's actually a whole bunch more that are actually really fun, but they tend not to fit on a single slide. So these are the three that we're just going to look at here. And so what happens is we have these analyzers, which are going to like analyze our training data. And it's implemented on a distributed data pipeline, aka BEAM. Yay! And so do plus data. This is like the model where I had the stork brought the data frame and the estimator get together on the cluster, and then the stork brings a beautiful new model. And so that's the analyze step is the stork that brings us our beautiful new model, ready for serving time. Okay, that worked better in North America. Maybe the stork thing isn't so popular here. I'm sorry. So right, we can use a bunch of things. We can like scale to a specific score. We can quantiles and bucketize and all of the things that we need to do pretty basic sort of feature preparation. The problem is like if you're going to go home and try and run this on your own computer, it's not going to work. If you're going to go home and run this on your own Google Cloud instance, which I'm sure you all have, totally going to work. And so why doesn't it work just yet? So we have this random branch on someone's personal GitHub, which is totally a great way to do software development. And it has a hacked up Python SDK that sort of talks to our cool new interface. And our cool new interface is really amazing. It supports Docker, some extra buzzwords, very cool. The only problem is we just didn't finish it. I'm sorry. This is like the kids showing up without their homework. But sparkle shoes. Okay. Anyway, sorry, I wanted to do that. So what is the state of this random collab branch? Which you can, you probably can't click on it here, but I'll upload the slides to my SlideShare and you can go click on it, is we can use Python sort of, Go sort of, and Java sort of on top of BEAM sort of with Flink. And it turns out when you combine three sort ofs and a portability layer that was created in the past quarter, you do not get something that is ready to train your deep learning model. So that's why there were a bunch of Spark-specific examples. But we're totally going to finish this. This line is going to turn from orange into black, and then it'll totally just be an ish here, and that'll be fine. That's one sort of, and one sort of is enough to train a deep learning model. If anyone like really wants to run word count on top of this new model, I'm not actually going to run this demo. It's boring as shit. But there's a Go word. Are there any Go developers? Cool. If you want some Google Cloud credits, come talk to me later. Yeah, there's a Go word count if you want. It's cool. It works. It follows the same sort of approach that we are following for integrating TensorFlow into Beam. And TensorFlow is sort of in Python, and we have to finish the Python SDK on Beam. We also have to make it work with Python 3, because, Google really loves Python 2.7. I don't know why. It's like the 90s, but with free snacks. And you can totally use it on top of Dataflow today. The nice thing is we can manage our dependencies because we specify the container image it's running on top of, rather than just pointing it at a yarn cluster. We point it at a yarn cluster and a Docker registry. Hey, containers inside of containers. What could go wrong? Turns out a lot, but we'll fix that bug, I promise. And you'll be able to, in theory, reuse your data prep code at serving time. And this is really useful because I have personally fucked up that copy and paste job before, where I'm just like and then I forget to update it, and then my model starts returning results which are impolite. And then, I mean, thankfully, I work in the Valley, and it's hard to replace engineers, so I haven't had to use my updated resume, but it's always a worry. Okay. What do the rest of the systems do? So it turns out that Beam is not alone in trying to integrate multiple languages. As we saw, Spark has an approach for handling this, as does Flink. And you might be like, Holden, maybe you just picked 3 really bad systems to try and train deep learning models on. And I want to tell you, it's not just those 3. Everything sucks. Let's see if I kept that slide or not. No, OK, so I'll just talk about it. So Kafka, I can sort of re-implement everything from the ground up in Python and C. That's so much fun. Hadoop streaming, it was like, yeah, Unix pipes. Unix pipes are cool. Ooh, Unix pipes are not cool. Dask is one system which doesn't have this problem because it's just in Python. So that's great. The only problem is it doesn't talk to any of my big data tools, like my file system. So that whole like getting the training data is like just a little bit of a tiny detail. Unless you're doing mnist, totally great for mnist. Best mnist training platform I have found yet. In all seriousness, they're working on improving Dask too. If any of these things are interesting, there's a bunch of GitHubs. Don't run this shit in production. When I give you a GitHub and a Jira at the same time, that says, oops. Sorry. So we're still going to fix this part up. Some more. And I will do some other shit in the next little while. I can go back to this one if anyone... Yeah, if anyone wants to take a picture of the references slide, we can leave it up for a second. OK, done. So upcoming talks. Before Kafka Summit, I'm going to do a Spark live code and review session. So you can see like how changes in Spark happen, how things like Arrow got integrated into Spark. I'll be talking at Kafka Summit about other things. And if anyone really wants an excuse to go to San Francisco, we're not going to talk about Beam there, but I will show you how to integrate Arrow into more parts of Spark. Yay! We can use it for more deep learning or adding 2 integers together, whatever your bag is. It's all good. And so that is, I have some bonus slides, but that's the main content that I was planning to present. If anyone has questions, now would be a lovely time for us to do questions. Or we can go into the bonus slides and or questionable demos, which may or may not crash my laptop. Questionable demos? OK. Oh, God. Fuck. I'm going to press this button really quickly and go back to the logo screen, just because I don't actually know what's in my terminal. OK, that's fine. There's nothing secret there. Yeah, totally. That's not my laptop. That's my laptop. That one looked like it was going to work, so that was clearly not mine. OK, so exciting news already kicked off with the Wi-Fi, so we're at a good start for demo time. Ooh, yes. OK. Fuck. which demo would we gonna run? Let's do TensorFlowOnSpark with Arrow. Yeah. Okay, TensorFlowOnSpark with Arrow. That sounds like an exciting time. Oop, that might be secret. Start jump 2 is a very high quality shell script that is totally legit. Oh. It's fine, it's fine. These subnets are, it's fine, it's private, it's not readable. Oh wait, the other one, fuck. Okay, it's fine. Okay, it's connected, cool. Oh, actually this is another project, okay. What now? Oh. Oh, I'm going to zoom in so that everyone can watch me fail. Okay, cool. I'm connected to my cluster. Super exciting. Screen-dr. Ooh, I have a cluster. Assuming that my cluster has not fallen over since the last time I ran it, we will go ahead. Yeah, whatever. Cluster size 6 is tiny, but it's fine. Okay, I'm going to run it with an output to a logs file in case it fails so that I can debug it later. And let's go. Ooh, wait, where the fuck was I? Okay. And so this is I'll run a git diff so that you can see that this is indeed the fancy one where we use Arrow. Yes, so this is the Arrow version of the code. Totally cool. 100%. I mean, you'll all believe me when the example fails, if it fails, because like the actual one should not fail. So mnist, Spark. Okay, let's see if this. Okay, no, that's cool. That's cool. That's cool. I saw a thing and I thought it was a stack trace. I'm not like super optimistic today. Okay, so one of the things that I changed about this is in the TensorFlowOnSpark examples, they have it so that you have to like send a bunch of properties about where your jars are, and that sounded annoying. So I switched it to use the Spark packages mechanism. So at a slight cost of the startup time every time it goes in and resolves all of the jars from my local Maven cache, it's fine. It's more compatible with my laziness because I don't remember such environment variables. Okay, cool. We're starting our Spark nodes. Yay! Do. We have some worker. Fuck. Okay, let's try running the demo a second time and seeing. Oh wait, no. Wait, did it crash? Okay, one of the nodes crashed, but it's all right. It's Spark. It'll recover from exceptions. It's great. Just ignore the performance implications of having to restart that job. Okay, cool. Keep scrolling. Ooh, I have a worker. I have another worker. I have worker 0 registered after worker 1. I'm sure that's probably the worker who decided to go for a little bit of a break. Yeah. Cool. It loaded the old cache model because I didn't give it a new name. I should have given it a new name. It started our master session. Yeah. And now it's connected. Everyone's happy. It starts feeding the partitions. The partitions right now are map objects. And this is because I have to do a map to turn it into the tuples, which the feed dict expects. And so we need to finish making it so that I can just feed the Arrow objects all the way through directly rather than having to map them into Python objects. But this is good. It's actually feeding data. That's exciting. Although error, oh, okay, executor equals 1. Whew. I thought that was error equals 1. Cool, that's great. Running, feeding, cool. This is starting to get boring. Let's go down to the end and see. Yay! So it trained on this many records, which isn't a lot. But on the plus side, the demo actually finished. We got our new fancy mnist model. It's probably worse than the one I can download off the internet already, but I trained it with Arrow, so that's cool. Okay, Yeah, that was the demo. The other demo which I can show you is Go on Beam on Flink. I feel like I might show the one Go developer that demo later if they're interested. And for the rest of you, I'll save you from the standard word count example if you promise not to report me to the union. There's some union requirements around the word count examples and the word count demos being in every talk. So if y'all are cool and y'all won't snitch, we good. Does anyone have questions now? Does anyone want to see the stack trace where it failed on one of the workers randomly? Anything? Anyone want sparkle shoes? I want sparkle shoes. Oh, it's got a sock on it. That's much less cool. Okay, so unless anyone has questions, we're done. I'll be outside and I can answer like questions one-on-one and or show that one Go developer the really cool word count example. It's totally okay. You don't have to come. Thank you all for coming. Have a wonderful day.